Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh and good morning. Dear students, BS Physics, Semester 1, Mechanics 1, Course Code 1103, Lecture number 15, Chapter number 5, the first lecture of Chapter 5. The name of chapter is the Newton's Laws of Motion. This lecture is headed by the Newton's first law of motion. I am talking with you, Rashmat Ali, Assistant Professor of Physics, Khaja Farid, Government Postgraduate College, Ramia Khan. The material of this lecture has been taken from the first book, Physics for Scientists and Engineers, by Sir Javet. The second book, Fundamentals of Physics by Halliday and Resnick, also by the Gerald Walker. The main contents of this lecture: the dynamics and the concept of force, measuring the strength of force, and the Newton's first law of motion. This is the title of the page diagram, the chapter diagram. First of all, the dynamics. As in the previous chapters, we have studied about the mechanics. The course name mechanics. Mechanics has the two branches. One of them is kinematics, another is dynamics. So for the dynamics, the study of motion with reference to force and mass is called dynamics. Motion is described in terms of force, momentum, torque, where mass is also involved in it. So we study about the force. The dynamics basically is a relationship between the force, mass, and acceleration. In some cases, force is even present, but acceleration is zero. Basically, this is a triangle: mass, force, and acceleration. So first of all, we want to introduce with the force. The force, the common term used in the mechanics, an agency that stops a moving body or tries to stop. In other words, moves a stationary body or tries to move it is called a force. Similarly, if somebody is standing, is stationary, is at rest, we can apply the force. In some cases, we are able to move the body. As a table, if we apply a force, we will be able to move it. And in some cases, it is impossible to move it. Suppose a heavy trawler or truck is standing there somewhere. If we apply the force, the truck will not be able to move by our force. Then it means the body is not able to move the force, but it has tried to move. Similarly, if a moving body, a ball is coming towards us, if we try to catch it, we will be able to stop it. Its motion will be reduced to zero. In some cases, if a coal tar drum is falling towards us, then if we try even the force, we will not be able to stop it. Similarly, a car moving, we cannot stop it. So, force is agency that tries or tends to move or stop. Similarly, another definition, an agency that tends to produce acceleration in the body is called a force. There are many examples in daily life where force can be explored, as shown in some figures. We can see as the first force, a spring. If we are applying a force with direction blue arrow, we will be able to pull the spring. Similarly, if we apply a force on a cart by string, along the forces along the string, we are able to move it. If we apply a force on the football, it will be kicked in the direction shown. So, some other examples too. A force when two bodies are placed nearby each other. This is a gravitational force, and also this is a Coulomb force, and this is the force between two magnets, or a magnet, a bar magnet, and also an iron filling or iron piece. The force is applied on the iron piece is shown by arrow. These are some examples. We want to know about the net force, or resultant force, or unbalanced force, or total force. Sometimes we apply only a single force. We can measure it, check it, judge it, but sometimes there are more than one force acting on the same body. Then the sum of these forces is called resultant force. Force is a vector quantity. It has magnitude as well as direction. So, the resultant force has the magnitude as the combined effect of all the forces, and direction from initial force to final force. Resultant force is basically the vector sum of all the forces. If forces are vectors, then we can find the resultant force by the head to tail rule. The case for the more forces acting on the body, we can obtain the equilibrium position situation. What is equilibrium? One of the statements of the equilibrium is that if the sum of forces, all the forces acting on the body is zero, then the body is said to be in equilibrium. This is the vector sum of forces that results in zero. Under equilibrium, the body is either at rest or moves with uniform velocity. In other words, the body has zero acceleration. So, if a body is at rest, it does not mean that no force is acting on it. Or if a body is moving with uniform velocity, it does not mean that only one force is acting on it. Bodies at rest are moving with uniform velocity. Certainly, there will be more than one force. The resultant of all these forces are net forces. Net force will be considered as a zero. And under this situation means rest and uniform velocity, the body will be considered in equilibrium. There are types of forces: contact forces and the field forces. These are the two types. The contact force, we can define it as the force which requires physical contact for their transmission from one body to another body is called contact force. Forces exerted by molecules. A boy pulling a trolley by a string. In the above diagram, we can see these forces as a spring, trolley and the football. These are the contact force. Unless we produce a contact direct with body or with by a string, these forces cannot be transmitted. The other forces are the field forces. The forces which do not require a physical contact but act in a certain region of space or region are called field forces. So many examples are there: gravitational force, Coulomb force, magnetic force. This diagram shows the contact force and the field forces. I have seen this is the field force between two masses. This is also a field force between two charged particles, positive and negative. This is also a field force between a bar magnet and iron piece. Some concepts are more about the force. There is the fundamental forces. In universe, there are two types of forces. One of them is the fundamental forces, and others are the drive forces. In order to develop models of macroscopic phenomena existing in the matter, it is believed that all matter is bound due to fundamental forces. Certainly, the fundamental forces are the field forces. 5 forces were named as field forces as fundamental forces previously: gravitational, electrical, magnetic, weak nuclear force, strong nuclear force. But later on, it was found that magnetic force has the same origin as that of the electric force. In other words, magnetic force is generated due to the electronic motion. So we combine the electric and magnetic force in the form of electromagnetic force. Now there are 4 forces considered in the universe. There is some other development we see in the coming lectures. The weak nuclear force and the electromagnetic forces are also same. We will study in future the electromagnetic weak force. Next one, as we have studied that force is a vector quantity, means it has both magnitude and direction. The strength of force, that is the magnitude of force, can be measured. So how is it possible to measure the force? Initially, we take an activity for the measurement of strength of force. Consider a spring balance is attached to a support. The first case is that when a force F1 is applied at the hook, the extension is produced, as we see from this spring. A spring is attached with the hook by a support. Another force F1 is applied on the spring. We can see the reading on the scale that shows the extension. If force is doubled, then we can compare the readings of both springs. The first spring indicates the reading 1, means 1 centimeter, 1 unit of length. The second shows the 2 unit of length extension. F2 is the force. We have made twice the F1. Similarly, from distance, we can measure the strength of force, how much is it. So, when both forces F1 and F2 are applied on the same spring balance in the downward direction, the resultant force can be written as F is equal to F1 plus F2. That is the vector form. Here boldface are used, not the arrowhead above the vectors. And the downward force is the resultant force produced by this. This is shown by the third spring. F1 and F2 both are applied in the downward direction. As F1 produced 1 unit length extension and F2 produced 2 unit length extension, if we combine them, F1 and F2 in the same downward direction, the displacement will also be combined, that is 3 units. 1 plus 2 is equal to 3 units. Now, F1 acts downward and F2 acts horizontally. The resultant force again can be written with the same formula. F is equal to F1 plus F2. But F makes an angle theta with the horizontal, which has the same effect as the combined effect of two forces. We can see from the spring diagram, as F1 is downward direction and F2 is in horizontal direction, both of the resultant F, and that makes an angle theta with the horizontal F2 force. This activity shows that the force has magnitude and direction, so for resultant, head-to-tail rule is applied. We have cleared up our concept of force. Before going to what's the Newton's laws of motion, it is necessary to know about the man, the scientist who worked for the force, Sir Isaac Newton, English physicist and mathematician. Period is 1642 to 1727. Isaac Newton was one of the most brilliant scientists in his era, in his time, in history. Before the age of 30, he formulated the basic concepts and laws of mathematics. He discovered the laws of universal gravitation and invented the mathematical methods of calculus. As consequence of his theories, Newton was able to explain the motions of planets and ebb and flow of tides and many special features of the motions of the moon and the earth. He also interpreted many fundamental observations concerning the nature of light. His contribution to physical theories dominated scientific thoughts for 2 centuries and remain important today. This information is taken from the survey book. You can see on the survey book on the side title. Isaac Newton also have given the 3 laws of motion. In this lecture, Newton's first law of motion is going to be studied. We can state this law: in the absence of external forces, when viewed from an inertial frame of reference, an object at rest remains at rest, and an object in motion continues in motion with constant velocity. This law tells the situations of motion in absence of force. It allows us to define force as that which causes a change in the motion. If a body is at rest, means no force is acting. If a body is moving with uniform velocity, means no net force is acting. Basically, first law of motion describes that acceleration is produced only when force acts on it. When no force is acting on the body, it has 0 acceleration, or the body is at rest or moves with uniform velocity. If a body has 0 acceleration, then it means that body is in equilibrium. Newton's first law of motion is also called as a law of inertia. A small look at the history for the laws. Before 1600, scientists believed that the natural state of matter was the state of rest, because they didn't know why the body is at rest appears so. Galileo was the first to take the different approach to motion and natural state of matter. He performed many experiments and concluded that it is not the nature of body to stop once set in motion, rather it is the nature to resist changes in its motion. So many examples are available in daily life. A spacecraft drifting through the empty space with its engine turned off will keep moving forever. So, if no force is acting in the space, the engine continues its motion with uniform velocity. A book lying on the table will remain there until somebody picks it up. So, it is again the absence of force, external force. With this, the lecture comes to end. So thanks for listening and watching with patience. Allah bless you all.